Okay, on this worksheet, you were asked to solve absolute value equations. So remember the algebraic process you use to solve those equations. You've got to show the work if you want full credit. All right, so when solving an absolute value equation, remember in the lessons, you were told, you saw that to solve this absolute value equation, you want to isolate that absolute value expression by itself. And it already is here. All right, now keep in mind that this is an absolute value equation. The absolute value equation is not the same as, don't say that's a linear equation. This is an absolute value equation, not a linear equation. The graph of an absolute value equation is not the same. I'm sorry, the graph of an absolute value function is not the same as a linear function. Okay, so keep that in mind. But we saw this. We saw that if you want to solve this absolute value equation, what we did was we rewrote it as two equations. Okay, and we did it this way. And notice that when we rewrote it, you see that 7 on the other side. You're going to notice what's going to happen on one of those equations here. So when we rewrote it, when you rewrite it as such, remember the absolute value bars are no longer shown. So when you split it apart, when you write it as two equations, you should no longer show those absolute value bars. The absolute value bars should be shown here. When you split it apart, no longer absolute value bars. Okay? So the two equations, you got to think about what goes here. Well, one of the equations is easy because all you do is just rewrite what you see without the absolute value bars. So your expression inside the absolute value bars is 3x minus 2. So you say 3x minus 2 equals 7. So there's one of your equations. Then we saw the definition of an absolute value expression. So remember, that's a distance that number is from 0. And we talked about why on the other side you took the opposite of 7. So notice that inside expression that's within the absolute value bars, you rewrite it like this, and then you're going to say 7, negative 7. So those are opposites. All right? And notice what we just did. So we took an absolute value equation and we wrote it as two linear equations. So the solutions will solution will be here and it will be here as well. Okay? So you can have two solutions. All right, so let's go ahead and solve these linear equations. I'm going to add 2 to both sides. So when I combine like terms, I get 3x equal 7 plus 2 is 9. Divide both sides by 3. One of my solutions is 3. Okay, so there's one of my solutions. The next one, add 2 to both sides. I get 3x equal a negative 7 plus 2 is a negative 5. Divide both sides by 3. What you do to one side, you got to do to the other. You have to do to the other, so make sure everything you write is mathematically correct. 3 divided by 3 is 1. 1 times x is x. I get x to be a negative 5/3. So there's your other solution. So those are your two solutions. All right, let's just check one of them. We're not going to have time to check all of them, but I just want to remind you how to check those. And we're going to go ahead and check the fraction, because checking this one is easy. Let's just check this one. So negative 5/3. So we're going to check x equal negative 5/3. So in place of x, you're going to substitute negative 5/3. And always go back to the original, the one with the absolute value bars. So you have the absolute value of 3 times a negative 5/3 minus 2, the absolute value of that, and I want to see if that's going to equal 7. All right, well, let's talk about 3 times a negative 5/3, right? 3 times a negative 5/3. Well, when you multiply these, that's multiplication here. When you multiply these, first of all, the 3's divide out, and you get 1 times a negative 5 is a negative 5. So this right here becomes the absolute value of negative 5 minus 2. A negative 5 and a negative 2 is a negative 7. Remember, still absolute value bars, and the absolute value of negative 7 is a positive 7, which is what this is. All right, so that's why negative 5/3 is a solution, because it makes that original equation a true statement. All right, so the solutions to this equation, there are 2 of them. These are the solutions. There are no other solutions. All right, so number 2. Let's talk about number 2. All right, here's number 2. I have the absolute value of negative 5x plus 4 minus 3 equal 7. All right, so remember we talked about you must, before you split it apart, before you write it as 2 separate equations, and notice nowhere in here, nowhere in this little part here, do you see absolute value bars. Okay? All right, so when you split it apart, no longer absolute value bars. But before you split it apart, you must get the absolute value expression by itself. So notice I must get this right here by itself. So that means I got to add 3 to both sides next, right? Okay, so let's go ahead and add 3 to both sides. So I get the absolute value of negative 5x plus 4 is now equal to 10. Now notice that this right here looks like this now. So now at this point, this is where you're going to rewrite it as 2 equations without absolute value bars. So the first thing you do is just rewrite this without the absolute value bars. So you're going to say negative 5x plus 4 equals 10. And then you're going to say negative 5x plus 4 equals a what? What's going to go here? This is 10. This is going to be what? Negative 10. And those are your 2 equations. All right, so let's go ahead and solve each linear equation. So I went from an absolute value equation to 2 linear equations. So let's go ahead and subtract 4 from both sides. So I get negative 5x equals 10, subtract 4 is 6, divide both sides by negative 5. I get x to be negative 6 fifths. So there's one of your solutions. Over here, subtract 4 from both sides. I get negative 5x equals a negative 14, right? Divide both sides by negative 5, like this. When you do one side, you do the other. Since I'm dividing, you've got to show the division symbol. These divide out, so you get 1 times x is x equal, now you are expected to know that a negative divided by negative is a positive, so you must say 14 fifths. Now if you want to write these as mixed numbers, you can, but those are your 2 solutions. You can leave them as improper fractions. They are reduced, but if you want to change this to a mixed number, you can. 5 into 14 is 2 with remainder 4, so you get 2 and 2 fifths. Over here, that's going to be negative 1 and 1/5. Okay? All right, so that's it. That's all you do. It's not difficult at all. You just got to remember, though, you have to isolate that absolute value expression by itself before you rewrite it as 2 separate equations. And notice nowhere in here do you see absolute value bars. All right, number 3. So number 3, we have this. We have and number 3, we have 4 times the absolute value of x minus 3 plus 5 equal 8. All right, so again, I need to isolate that absolute value bar first. So I see a 5 here and I see that 4. So let's just deal with that 5 first. So just like we did in number 2, where I had that subtract 3. So I added 3 to both sides. So here, I'm going to go ahead and subtract 5 from both sides. So I have 4 times the absolute value of x minus 3 is equal to 3, right? 8 subtract 5 is 3. Okay, now the next thing you're going to do is you're going to divide. So you want to get that absolute value expression by itself. All right, now we did talk about in class, if this is positive right here, you could have distributed. But some people overgeneralize, and if this were negative and you distribute, then you're going to have an issue. It's no longer equivalent. Okay? So you got to be careful. So let's just go ahead for right now and do what we said to do in our steps, and that was to go ahead and divide both sides by 4. Now notice I know, and so the 4's divide out. I know I introduced a fraction, but we can deal with that. We can deal with fractions. So I have the absolute value of x minus 3 is equal to 3/4, right? Okay, so now I'm going to, once I get that absolute value expression by itself, I am now going to rewrite it as 2 separate equations without absolute value bars. So I'm going to say x minus 3 equals 3/4. So you rewrite just what you see without the absolute value bars. And then the other solution is going to be x minus 3 equal a negative 3/4. And then all you do is solve for x. So let's go ahead and add 3 to both sides, just like this. All right, so I get x equal. Now this is a little bit more work because I don't because those are not integers, so it's a little bit more work. But I want you to remember is this: you have a whole number and a fraction. That's a whole number, right? So adding those is very simple. 3 and plus 3/4 is 3 and 3/4, right? It's just that mixed number. And so as an improper fraction, you can now write this. So that's the solution, by the way. And so as an improper fraction, 4 times 3 is 12. 12 plus 3 is, 15? So you got 15/4. Okay? Now let's do this one. Add 3, add 3. So I get x equals. Now you got to be careful here. See, this one was easy only because they were both positive. So a positive 3 and a positive 3/4 is 3 and 3/4. Here, though, you got to be careful. One's positive, one's negative, so that's not as easy to get right away. So let's think about this. You have 3 minus 3/4, right? 3 minus 3/4. So some of you know that 3 subtract 3/4 is 2 and 1/4. All right, 2 and 1/4. But some of you may not see this right away. So here's what you would do. Let's go ahead and find the LCD. So the LCD is 4. So you're going to write two equivalent fractions with that denominator 4. So 3 over 1 is equivalent to what fraction with the denominator 4? Well, 1 times 4 is 4. 3 times 4 is 12. So that makes sense, right? Because 12 divided by 4 is 3. Here, the denominators are already the same, so the numerators have to be the same. So now 12, now the denominators are the same now. So 12 subtract 3 is what's that, 9? And 9 divided by 4 is 2 and 1/4, which is what we had here. So the solution here would be either 9/4 or 2 and 1/4. Okay? But some of you probably did this, and let me just rewrite this part over right here. So some of you probably did this. Okay, and since this is positive, since that's positive, and you distribute, you'll still get the same solutions. So let's go ahead and do that. So you probably said, now I'm going to tell you this though, if this were negative, you did this, you're going to lose all your points because mathematically those equations are no longer equivalent. You cannot, this is negative because that's absolute value bars, not parentheses, but if this is negative, you cannot distribute a negative number within those absolute value bars and think that those two equations are equivalent. They're not. Okay? But since that's positive, I could have distributed, and so you would have said the absolute value of 4x minus 12 equal 3, just like that. And then rewriting it as two separate equations, you would say 4x minus 12 equals 3, 4x minus 12 equals a negative 3. And then solving each linear equations, notice you no longer have absolute value bars, so adding 12 to both sides, I get 4x equals 12 plus 3 is 15. So dividing both sides by 4, I get x to be 15/4. So there's one of my solutions, which I knew, right? Because I have 15/4 here. Over here, adding 12 to both sides, I get, combined like terms, I get 4x equal negative 3 plus 12 is 9. Divide both sides by 4, I get x to be 9/4, which I knew was going to be a solution because I have 9/4 here. Okay? Just letting you know though, if this is negative and you distribute and you overgeneralize, which is what's happening, you're not making connection between what this means, you're going to lose almost all your points. Okay? Alright, so that was number 3. Let's get to number 4. In number 4, we have this. In number 4, we have absolute value of 4x plus 3 minus 7 equals a negative 3. All right, so same thing. You're going to isolate the absolute value bars. So you're going to add 7 to both sides. That will be the first thing you're going to do. And so when I combine like terms, I get the absolute value of 4x plus 3 is equal to negative 3 plus 7 is 4. All right. Once you get the absolute value bars by itself, then you're going to rewrite this as two equations without absolute value bars. So you're going to say 4x plus 3 equal 4. So just write what you see without the absolute value bars. Or the solution will come from this one. 4x plus 3 equal the opposite, negative 4. Right? Okay. So solving each linear equation, you subtract 3 from both sides. So I get 4x equals 4, subtract 3 is 1, divide both sides by 4. I get x to be 1/4. Okay? So there's one of your solutions. So your solution to this will be either 1/4, well actually it's 1/4 and whatever you get here. And over here, subtract 3 from both sides. I get 4x equal a negative 4 and a negative 3 is a negative 7, right? Divide both sides by 4, I get x to be negative 7/4. So there is the other solution. All right, so you write this as two equations, this equation and this equation. All right, so you can write this and this really should be and 4x plus 3 equals 4, and you need to also say 4x plus 3 equals negative 4, right? Okay. All right, so that was number 4. Okay, so now let's look at number 5. So we have 2 times the absolute value of 3x minus 1 minus 3 equal 7. Okay, so I'm going to add, so remember we got to get that absolute value expression by itself, so let's go ahead and add 3 to both sides. And so when I combine like terms, I get 2 times the absolute value of 3x minus 1, this is 0, equal 7 plus 3 is 10. All right, now let's go ahead and get rid of this 2. So let me go ahead and rewrite this over. So I know that this is positive, so you could have distributed, since that's positive, but it's negative and you do that, you're going to have an issue. So dividing is not going to be difficult because 10 is divisible by 2. So let's go ahead and do that first. And so when you reduce, you get the absolute value of 3x minus 1 is equal to 5. So once you get the absolute value bars by itself, you're now going to rewrite this as two separate equations without the absolute value bars. So to rewrite this, you're going to say 3x minus 1 equal 5, or 3x minus 1 equals a what? Negative 5, right? Okay. So notice that what's inside here, the absolute value bar, that expression, you see it twice listed, and then this number, these are opposites, 5, negative 5. That's how it's always going to look. Okay, adding 1 to both sides, I get 3x equals 6. Divide both sides by 3. One of my solutions is 6 divided by 3, which is 2. Over here, adding 1 to both sides, combining like terms, I get 3x equal a negative 5 plus 1 is a negative 4. Divide both sides by 3. The other solution is negative 4/3. So those are your two solutions. All right, and that was it. So that is the key to the worksheet on solving absolute value equations. Just make sure you know what's required for work to be shown. Okay, so you need to kind of show this. Then when you split it apart, and you have to do that, then make sure that your two equations do no longer have that absolute value bars, and you need to solve it, and those are your solutions. Okay, so that is the key to solving absolute value equations.